Hello everyone, I'm Diego Souza from MPay, the Brazilian National Institute for Space Research, and focal point on satellite data requirements for Regional Association 3. First of all, it's really great to be able to collaborate in this coordination meeting. Thank you very much for the invitation. This is the third year that we represent our group on this joint coordination meeting, so we really appreciate it. And also, I would like to acknowledge my colleague Marcel Garbanzo, professor from the University of Costa Rica, which is also a focal point on satellite data requirements, but for Regional Association 4. And he's the other co-chair of the WMO Coordination Group on Satellite Data Requirements, also known as the SDR group. I'm going to start this report showing some introductory information about the RA3 and 4 SDR group, and then present some of the recent key activities of the group, including actions in support of early warnings for all. Basically, the mission of the SDR group is to act as a connection between the satellite operators and the satellite data users, and to facilitate the use of satellite data throughout the regions 3 and 4, and from data requirements to data utilization and all the steps in between. So the group facilitates the interaction between satellite data users and our regional setups like NOAA, CONAI from Argentina, and MPay from Brazil. And right now, we have active participation from 18 member countries from both regions, including participants from 3 VLab Centers of Excellence, which is a very important part of this regional engine, as we call it. And this is a timeline with a high-level overview of the group's history. And the group meets in person at least every 2 years, usually in the weekend prior to the NOAA Satellite Conference. And to ensure the continuity of our actions, we usually have 2 to 3 teleconferences per year. So in the past 11 years, we have worked on 39 actions and organized 5 face-to-face meetings, 35 teleconferences, and worked on the distribution of 5 regional surveys. And we have an average of 30 to 40 participants during our teleconferences and in-person meetings. And to communicate with our community, for formal announcements, we use the group's mailing list, which currently has more than 90 contacts, including our setups. And from our experience, the most efficient way to interact with the community is through social networks like WhatsApp groups. And we have plenty of them with dozens of participants to discuss GOES-R related issues, GeoNetcast, data processing and visualization, post-training conversations, and so on. And this year, we also started organizing virtual workshops like this one on satellite data access from the cloud, where regional experts share their experiences. And we've had very good results in terms of interaction with 300 participants in our latest workshop. And in terms of data access, we basically have 4 categories of mechanisms in the region. First, direct readout and rebroadcast systems with the antenna pointed towards the satellite of interest. We also have cloud services like the NOAA Open Data Dissemination Project, also known as NOD, which provides real-time data through the Amazon Web Services, Google Cloud, and Microsoft Azure. And also Unidata and UMETSAT have a variety of mechanisms for data access through the internet. And for historical data, we have NOAA and also the UMETCAST Data Center. And there's also several web pages with real-time imagery like Cirrus LiDAR, for example. And the SDR group tries to document all the received stations in the international community. And we have a dedicated web page for that. On the left, we have all the GOES-R GRB stations outside the US as reported by our members. And on the right, we have the HRD stations receiving LEO data. As for GeoNetcast Americas, we have documented almost all the stations, and most of them have been installed by the organization's technical staff using off-the-shelf components, which is much cheaper than the so-called turnkey solutions. And since Go16 was launched back on 2016, the system's bandwidth increased from 2 megabits per second to 20 megabits per second, and we had a considerable increase in the number of stations. And the SDR group discussed on several meetings which datasets would be included on the broadcast. And in 2022, the group distributed a regional survey on the use of satellite data, and we received more than 200 responses from more than 30 countries. And one of the things we can clearly see is the importance of data access through the cloud for this generation of satellites. And we can see that the internet is considered the main data access mechanism for both goes east and goes west satellites. And having this high-level overview of the regional data access mechanisms used by members really facilitates the development of project proposals and coordinating actions to ensure members are able to receive systems according to their needs. Regarding data access and visualization tools, we don't have software solutions offered by setups, nor a unified solution across member countries, so each organization chooses or develops their own visualization tools. In the US, for example, the National Weather Service, they use the AWIP software. In Canada, they reported they are using Ninjo, which is another meteorological workstation. And in some Caribbean countries, they are using the Proteus software by EEC. And in Chile, they reported the use of visual weather. So there are different solutions being used by the community. However, if we consider the general community, based on the last regional survey, Python is by a great margin the most used tool to process data from both GEO and LEO satellites. And regarding visualization interfaces, Cirrus LiDAR is the most used interface to visualize GEO data from GEO satellites, and NASA Worldview to visualize data from LEO satellites. And considering that most member countries develop their own visualization solutions, in 2022, as a result from our latest face-to-face meeting, we created a task force dedicated to data access and visualization, where each member present their solution and the tools used to develop them, and also share the best practices and the latest technologies. And we invite international experts like the Pytro team to present their tools. And apart from the official teleconferences of this task force, we also communicate regularly through WhatsApp groups. And most members of this task force are also using Python to process satellite imagery, as also indicated by the regional survey. And the number of Python libraries available to process meteorological data really facilitates the process. And several trainings of the VLab initiative, during several trainings we have organized covering data processing with Python, demonstrating how to access data from the cloud, how to process it, and integrate different data sources. And now the community has a lot of experience having developed several resources on how to access and process data from GEO and LEO satellites, NWP data, oceanography data, derived products, and so on. And this year, we also organized a training on weather radars, including both theory and data processing, and it was very well received. So basically, anything is possible, and using a single tool like Python for all this hands-on activity really helps. And also, as we have seen on the results of the regional survey, Cirrus LiDAR is the most used web page to visualize satellite imagery in our region. It's an amazing tool, and one of our programmers in Brazil was able to create a similar interface called DSAT, using only open source tools. And during one of the teleconferences of the data processing task force, he presented how he created the interface. And we made this recording available so other regional developers could try to do the same. And we already have the first results, as some colleagues are being able to create similar tools. Okay, methods for upgrades. we basically have the community-driven and project-driven methods. And this is where direct communication via WhatsApp really shines. Here we have a recent example where some users in Brazil noticed considerable 5G interference on their GeoNetcast receive stations, which use a C-band. And we have a WhatsApp group with Brazilian users with more than 60 participants, and they exchanged information among themselves and shared the results they had using different filters and trying different LNBs, and who the vendors were, and in the end they were able to solve the problem. So this mutual support through social networks really help. And also, since 2017, we have been blogging how to assemble GeoNetcast stations, and many users in the region were able to assemble their own stations. It requires some work, but it's much cheaper than a turnkey solution, something around $10,000 in comparison to $40,000 to $50,000 for a turnkey solution. But we also have the community projects like this SDR project funded by USAID, which contemplated the installation of 7 new GeoNetcast stations on the Eastern Caribbean states last year. And right now, we are also discussing with NOAA and WMO a pilot project for the region, covering the installation of redundant receive stations using both satellite-based and internet-based reception working in parallel. Targeting higher priority member countries that do not have redundant means to receive satellite data or do not have any means at all. Another important topic to keep track is our regional nowcasting capabilities. And this year we started an interaction with the World Weather Research Program, which is led by our colleagues from Argentina, and this initiative provides a great overview of the nowcasting capabilities around the world, and including the nowcasting tools used in each region. If you don't know this webpage yet, we definitely recommend it. And here we have some of the tools used in RA3 and RA4, like 4Track for forecasting and tracking the evolution of configurable clusters, TATool developed by NPay for tracking and analysis of the life cycle of convective systems, LightningCast, which predicts the probability of GeoLAM observation of lightning occurrence in the next hour within a region of interest. And all of these tools are freely available for download and use. Now talking about some of the regional actions taken in support to early warning for all. First, we have the SDR workshops, which are focused on early warnings. And this July, the group organized the second workshop, which focused on satellite data hazard monitoring, with presentations from our colleagues from the US, Argentina, Mexico, and Costa Rica. And they share the available products and how their organizations are using satellite data to monitor these hazards. And it was a 3-hour virtual workshop with 300 participants, with great interest from the regional community. And the group is also working on a gap analysis, and this effort is basically divided in 3 steps. From members, we expect them to answer the survey that the group distributed this November, with questions asking about their priority hazards, the satellite data used to monitor these hazards, and their training needs. From setups to fill in the spreadsheet from the WMO data call, and from the regional experts to identify an initial list of products for each hazard that will be further validated by setups. And after that, with the satellite products that could be used and the products that are being used, we will proceed with the gap analysis in terms of data access and training. And finally, we will work in a regional implementation plan to address the gaps identified. And NOAA and other setups have already provided their input to the data call, identifying a list of products to monitor tropical cyclones, droughts, fires, floods, heat waves, and volcanic ash. And on the user side, talking specifically about this new survey, We distributed it a couple of weeks ago, and we expect to start compiling the results early next year. And it is available in 3 languages: English, Spanish, and Brazilian Portuguese. And this survey covers 5 topics: personal information, the top 5 weather hazards for a particular country or region, the challenges related to satellite data use, like technical limitations, visualization issues, and lack of awareness, and also questions related to the GOES-R mesoscale sector requests, and R2O and O2R. Another regional action taken in support of early warnings for all, now in the context of VLab, is this pilot project called VLab in support of early warnings for all. And the project started this October. And the objective of this project is to create regional online training materials to support the use of satellite data for monitoring the regional priority hazards. And each regional VLab Center of Excellence will create these training resources in their native languages, which is very important. And we expect that these resources are ready by June next year. And we should have a dedicated session about this pilot project during the NOAA Satellite Conference in August next year. And also we should organize a regional virtual workshop covering this content. And the first action of this project was to identify the hazard contributions from each VLab Center of Excellence to ensure a variety of hazards are covered for RA3 and RA4. And this action has already been accomplished, and on this table you can see the hazards that each Center of Excellence will be covering. And the idea is that in the future this pilot project could be extended to other regional associations. And that's it. This is our report for Regional Associations 3 and 4, and a general overview of the efforts of the SDR group related to the Early Warnings for All initiative. Thank you very much.